Okay, welcome to 2-6, solving equations with absolute value. All right, so absolute value, you guys probably remember kind of how it works, right? You take whatever number here. I have an A, right? You take whatever number is inside these brackets, right? They're not brackets, but absolute value, symbol, and then whatever that number is, you just make it positive, right? That's what you got probably taught before. Remember from pre-algebra or something. Whatever's in there, you just make it positive, right? And that's really the idea of all it is. But really, when you think about what it means in the world, in real world stuff, we're talking about distance or magnitude. And we've all heard about distances, right? How far away something is. And magnitude is similar. It's like how big or how great something is, but we don't care about which direction it went, or necessarily like maybe not the units or something like that. So we're talking about distance and magnitude with absolute value. So yeah, again, we'll take a quick look at this A equals 5. So we have two possibilities, right? And when we have a variable inside of an absolute value, we always end up with two possibilities. We can either have 5, absolute value of 5, right, equals 5, or absolute value of negative 5, right? You probably remember this from pre-algebra, equals 5. Okay, and that's the idea, is that we have two solutions. We've got A, so this implies, let me use the right colors. So this implies that A equals 5, right? Whoops. A equals 5 here. And this one implies that A equals negative 5, right? So because I can put in a 5 here and I get 5, and I put in a negative 5 here and I get negative 5. So, but it's kind of interesting to map this out and take a look at it on the number line. So let's do that really quick. So if we get 5 here, 4, 5, and then negative 5 here, negative 5 right here. So what's kind of interesting to look at, and we'll do this a lot more later in the class too, is to look at kind of the distance and the center point, because it's equidistant, right? That's the whole definition, is that this distance is 5, right? From some center point, or from some starting point, right? From a starting point, there's a distance of 5. We don't care which direction we're in. That's why the negative works and the positive works. Okay, so that's kind of the basic understanding. Maybe it helps a little bit. So let's move on to the next one. How do we actually solve these things right now, right? So basically, we can look at A plus 1 can be 5, right? For this example number 2, like this first one, we had A can be 5, or we had A can be negative, right? Whatever we had. So it's the same with a group. When we have a group of stuff inside, like a quantity that's not just a number. It's A plus a number maybe, right? So A plus 1 is 5, or we have A plus 1 equals negative 5. And that's literally how we're going to solve this problem, is we're going to do two problems. So lucky you, every absolute value problem is 2 in 1. So how do we solve this? Well, let's apply the inverse operation. What's happening to A? It's being added, so we're gonna add a negative 1 to both sides. Add a negative 1. The additive inverse of positive 1 is negative 1. Okay, and those will cancel. And if this is not looking familiar or kind of looking sketchy, just go back to some other videos, and we get positive 4, right? Okay, great. So A is 4. Good. And how about this one here? Similar situation. We're just going to apply the additive inverse. Negative plus a negative 1, or minus 1 is the same. Okay, I'll do it both ways. One is plus negative 1, one is minus 1. And same kind of thing. Sorry, that got a little jumbled up, but same kind of thing. And we end up getting A equals, that looks like a 9. Whoa, that's an A. Okay, A equals negative 6. Okay, and here's and then let's report our answer in the, you know, correct formatting and blah blah blah. So your answer will be the bracket. So A equals this bracket, and that's like a solution set, right? We kind of talked. You can do it in you know, least to greatest if you want, or you know, any order doesn't really matter. So there's your little solution set. This one looked a little sketchy, but now what I thought was kind of cool was to maybe look at this and see what happened to our center, right? Because remember we talked about how this absolute value is just a distance, right, from some center point, right? Okay, so we've got 0, 2, 4, 6. Let's do it that way again. 2, 4, 6, -2, -4, -6. Okay, and let's plot these points. Okay, so my blue one is going to be at -6 down here, and then my actually this would be a good point to pause the video and think about what happened to the center. Actually, my green here is going to be at 4. To kind of get a hypothesis before, but now you can see it, right? So let's see. Let's count 1, 2, 3, 4, 5. Right, here's 5 units. And then blue, 1, 2, sorry, from here, 1, 2, 3, 4, 5 units. So notice that. And it's kind of interesting because when you first look at it, you might have thought, as you know, I did when I was unfamiliar with this stuff, is that, okay, well, A plus 1, all right, well, I'm going to probably move my center, you know, is going to probably be at +1. But take a look, it moves actually to -1. So that we're 5 away, and it kind of makes sense because from that center point, I need to have that center point and one more, and that distance be 5. So think of it that way, maybe. Maybe that makes sense. Okay, let's try a couple straight up examples, and then this is the kind of stuff you'll have in your homework. But hopefully that was helpful too. Okay, so this is good old-fashioned just technique, right? All we do is we take our 7m plus 4 and set it equal to what we have, and then we take our 7m plus 4, remember it's just 2 problems in one, and set it equal to opposite of what we have, so that's just +8. Okay, so let's start with this one. Should I use I'll skip the colors and you guys can follow. So, you know, -4 here, and -4 here. Alright, 7m equals, what is that, 4 and 8, that's 12, right? -12. Same sign, take the sum, divide by 7, or multiply by the reciprocal, which is 1/7. You'll get the exact same answer. M equals -12 over 7. Cannot simplify. That's my answer. Not fully my answer. I shouldn't do a box yet. There we go. That's one part. I'll do a little bucket. How's that? How about this one? Apply the opposite, the inverse. Additive inverse, alright, additive inverse. Okay, and there's cancel, we get 7m. I'll cancel those two also right here. Cancel. We get 7m equals 4, +4, right? Difference sign, take the difference, right? And then multiply by 1/7, multiply by the reciprocal. Multiply by the reciprocal on both sides. Notice how I did one and then the other. It's exactly equivalent, same but different, as they say in Asia everywhere. M is +4/7. Okay, so those are our two answers, and we will finally write our solution set, right, is -12/7. So M can be these two things, is what the solution set means, right? Why do we write it like that? M is able to be these two things. And let's see if we can quickly do one more. Alright, so I'm going to do this quickly. 3/4. Okay, so please feel free to pause. It equals the exact same number, and then on the other side we have the same equation, and that equals the opposite number, right? Alright, so let's do it. Apply the additive inverse. It's +3, the additive inverse. Different sign, take the difference. 13. That's a -13, right? And that's 3/4. Okay. Then we're going to multiply. We're going to take the multiplicative inverse, which is the reciprocal, multiplying the reciprocal. Ooh, I'm running out of room here. Sorry about that. That's 4/3. 13 times 4. I don't know that in my head. I should. 3 times 4 is 12. 4, 5, 52. So that's negative 52 equals k, right? These cancel. Okay, that's our first answer. Additive inverse. Okay. Alright, I should cancel those two. Alright, so 3/4 k equals 19. Multiplicative inverse, right? The reciprocal. 4/3. Let me erase. Really close to my time here. We're almost going to make it 4/3. Oh no, 19 times 4. Okay, let's see. 19, this is my scratch work. 4 times 9 is 36. 4, 5, 6, 76. Positive 76 equals k. Bucket that. And then finally, my solution set. Ooh, that's an ugly bracket, but that's okay. 52, 76. Close bracket. Alright, and there you have it. There's a couple examples for solving equations with absolute values.